Okay, let's get into lesson 2 or 5.2, and this is now solving equations algebraically. So now we're going to be using some other methods. So besides just graphing, we're going to have to go through and actually solve these. So you're going to have to know how to do these. And so a lot of factoring, things like that, and then solving. Remember that our ultimate goal is to sign the equation equal to 0. So we have x times x minus 4. That means x equals 0 and x minus 4 equals 0. And then we get those two answers. This one is x plus 1 equals 0, x minus 2 equals 0. So therefore we get negative 1 and positive 2. This one, you can see I have two terms there. So what I can do is I can factor out an x. So I have x times x minus 7. And then I can do the same thing that I did right above here. X equals 0, x minus 7 equals 0, and I got it. And then this one is a factoring. So we have x squared minus x minus 6 equals 0. We have to draw the table. We have to determine, in this particular case, notice here the signs. This tells me one sign is positive, one sign is negative. The negative number is the larger number, so I have plus and a minus here. So I have 1 and 6, and 2 and negative 3. These two add up to negative 1, so this factors immediately to x plus 2 times x minus 3 equals 0. So x equals negative 2, x equals positive 3. Remember, because we set each one equal to 0. And then this one's a little different. So this one, we can do it this way. This is something you should recognize. I'm going to move the 20 over to the other side by subtracting it. Now you notice we have a difference of squares. I'm then going to factor that to x plus 10 times x minus 10. That's a special factor. That's just a memorized one. And so x equals negative 10 and x equals positive 10. So that's how we go through and we solve those types of problems. Okay, here are your standards. Lesson goals, we're going to factor and then put them in something called quadratic form. That gets a little bit more complicated as we do it. We're going to solve them by factoring. So first thing we're going to look at is the sum of cubes and difference of two cubes. So sum, if I have two cubes here, notice what it breaks down to. If I have a difference of two cubes, notice what it breaks down to. So for example, if I have x cubed minus 3 cubed, that's going to equal x minus 3. This sign will actually always follow that sign. And then I have x squared because this term is x. And then I'm going to multiply these two together. So I get plus 3x. Notice that this sign here and this sign here are opposites. And then on the last one, no matter what, it's always positive. And notice I have a 3 here. I square that and I get a 9. And that's how you do the difference of cubes. Okay, sum of cubes, notice the only difference between them are the signs here and the signs here. So that's really the only difference that we see in that particular case. Okay, so we are going to go over greatest common factor. So we're going to look at all the terms and see what we can factor out. Notice this has an a to the fourth, b to the third. This has an a, only a 1a and 1b. So the most I can take out is a 2, because I can take a 2 out of a 6 and a 2. I can take an a out of an a to the fourth and an a, and I can take one b out of a third and a b. That's what they do here, is take that out, and then we divide those out. Difference of two squares we did above. Sum and difference of two cubes is the same equation that we just did. Perfect square trinomials. So if I have something like this, x squared minus 10x plus 25, what we do when we're looking for those is we look at the last term and the first term. Are they both squares? So 5 times 5, yes. X times x, yes. Then what we do is we add up these two numbers here to see if it is the same number in the middle, and it is. Therefore, this factors down to x minus 5 times x minus 5. Notice that's different than the difference of squares. Notice that they are both the same sign, and this becomes x minus 5 quantity squared. That's why it's called a difference of squares. In this grouping one, I'm not going to explain it until we get to a problem, and the same thing with general trinomials. Okay, so combining cubes and squares. So notice we have a to the 8th minus a squared b to the 6th. So we have that type of problem there. We want to see what's common to both of them. So I can see that I can take out 2a's here and 2a's here. So I have a squared times, and remember whenever we take it out, we're dividing. So it's a to the 6th minus b to the 6th, because I took out 2 of the a's here and 2 of the a's here. Notice there's none left. And so I have that. Now this is looks kind of like maybe a difference of squares. Okay, maybe a difference of cubes. It's of that form. It's not exactly that particular problem, but it's similar to that type of problem. So we can kind of see what's going on in this particular case. But notice that one of my factors is a squared. So there it is right there, a squared. Okay. On the other one, though, what I'm going to do is I'm going to always break it down to a difference of squares first and then see what happens. And the reason is because a difference of squares is easier to work with. So what does that mean? That means I'm going to write it out as a cubed squared minus b cubed squared. And if you remember the rules of powers, these two multiply to each other. So this becomes a 6, this becomes a 6. So we get the exact same thing that we had here. And now we can do a difference of squares, but notice what I'm going to do first is I'm going to set x equal to a to the 3rd and y equal b to the 3rd. Now I'm only doing it just to show you what happens. This is nothing special. It's not a requirement. I like to do this because it's easier, because then I get x squared minus y squared, because y is b to the 3rd, x is a to the 3rd, and you can factor this. That's x minus, or x plus y times x minus y, because that's the difference of squares. And then we go back and resubstitute them in. If you remember, x is a cubed, y is b cubed. So we really have a cubed plus b cubed times a cubed minus b cubed. And now I can factor those. And from the rules above, that becomes a plus b times a squared minus ab, because we multiply those two together, plus b squared. And on this end, we have a minus b times a squared plus, because it's opposite sign, ab plus b squared. And that's how we write it out. So that means we have these other factors, a minus b, a plus b, and a squared plus ab plus b squared, and this one right here. So it'd be a minus b, a plus b, a squared plus ab plus b squared, and finally a squared minus ab plus b squared. So that's what we have when we write everything out. So that's what we've got in this particular case as we write these things out. Okay, so that was problem number 1. We have a lot of problems to get through. We're going to factor in this one by grouping. I'm going to do this on the next video because I'm running out of battery, and I'm going to get things plugged in. So I'm going to do that on the next video.